Looking at our world from space, it's easy to see why we call it the blue planet. 3/4 of the Earth's surface is covered in a vast, unbroken expanse of ocean. But if we run a thought experiment and peel away every drop of that surface water, gathering it all into a single, isolated ball right next to the dry planet, you can see there really isn't that much of it. Compared to the massive, rocky bulk of the planet, that little sphere of liquid is remarkably small. Yet, that thin film of moisture makes our world entirely different from any other rock in the solar system. It is the single defining feature that controls the climate, the coastlines, and the destiny of life itself. Rewind 4.5 billion years, though, and the picture looks completely different. When our planet first formed, it was a molten, bubbling inferno. The surface temperatures were so extreme that any liquid water trying to settle there would instantly boil off into space. A sphere made entirely of searing magma physically rejects moisture. There is simply no place for an ocean to exist on a world of liquid fire. So if the young Earth was born into an environment entirely hostile to liquid water, how did our massive oceans actually get here? The answer starts deep underground. While the surface was boiling, the raw chemical ingredients needed to create water survived by remaining safely locked away deep inside the Earth's mantle. Over time, the outer crust began to cool and harden. This immense internal pressure eventually ruptured, creating the planet's very first primitive volcanoes. These eruptions expelled heavy rock and molten magma, but they also aggressively vented highly pressurized steam out of the fractured crust. As millions of tons of this volcanic vapor hit the cooling atmosphere, it formed dense, heavy clouds. Soon, it began to rain, and that relentless downpour continued for thousands of years. This torrential rain slowly gathered in the low-lying basins of the newly cooled crust, gradually forming the earliest shallow seas. This bar chart represents the total volumetric capacity of our modern oceans. As it fills up, you can see that the water produced by Earth's internal volcanic outgassing stops precisely at the halfway point. The planet's own heat only generated 50% of the water we have today. To account for that flashing empty space at the top of the chart, we have to look away from the Earth entirely. The rest of our water had to come from deep space. The early solar system was filled with comets, massive 4-mile-wide objects wandering through the void, composed entirely of rock and ice. To verify exactly how much ice these objects carry, scientists launched the Deep Impact mission in 2005. Their objective was to intercept a comet and dig into its core. They achieved this by deliberately crashing a massive space probe straight into the comet's surface at high speed. The resulting debris plume provided the hard data they needed. That single impact excavated more than 250,000 tons of water right out of the rock. This confirmed that comets are incredibly efficient, pre-packaged delivery vehicles for water. Now, shift the timeline back to our young planet, just after those volcanic rains had filled up the shallow basins. During its formative years, Earth sat right in the crosshairs of a heavy cosmic bombardment. Thousands of these icy comets slammed into the surface. With every strike, their massive payloads of ice instantly melted and mixed perfectly into the existing pools of volcanic rain. By the time the bombardment finally stopped millions of years later, these external impacts had successfully delivered the missing half of the Earth's total water volume. The hostile, chaotic environment eventually stabilized, leaving behind a world completely enveloped in the deep blue expanses we recognize today. For nearly 4 billion years, that water has continuously carved out the coastlines, regulated the global climate system, and sustained every known biological process. And every drop of it carries a dual history. Exactly half was forged in the extreme heat of the Earth's rocky mantle, and the other half was delivered by the freezing ice of deep space. The blue planet is actually a lasting, liquid monument to a remarkably violent cosmic birth.